Well, here we are in the lab again, and last time we defined our what we're doing a little bit better, and then we signed up for a Fusion 360 account, and hopefully everybody like played around with Fusion 360 a little bit, try to figure it out. It's not really complicated. But, any software, it takes a while to get into the groove. Once you have an idea of what you're making, you're going to have to make some kind of schematic, because you're going to have to build the circuit eventually, And the first circuit you're going to have to build is one that I call it to qualify your idea, because you got your idea, and then you got to build a little circuit to see if it's going to work, and you have to make adjustments and tweak it into doing what you want it to do. And in order to do that, you kind of need a schematic, start building a schematic. And then from the schematic, Fusion 360 starts putting the parts on your board. So with Fusion 360, you need three things. You need a schematic, a PCB, and a library. So the schematic is obviously the schematic of your circuit, and that's linked directly to the PCB. So when you add parts to your schematic, those parts automatically get put in your PCB file, but you have to place where you want to put it, but it places it in there. So you have to have a part defined, and the library is a collection of your parts for your board, and it defines the footprint, the symbol for your schematic, and the 3D image for this, because also your PCB is linked to a 3D PCB image to give you an idea of what the finished product is going to look like. And the better your 3D models, the better they look on the board. And there's different places that you can get 3D models, and the footprint and everything. And so DigiKey usually has links. There's some different ones. We'll get into that here shortly. And then I have a domain called antimatter.me, and there'll be a link up here. And so I put a public directory on there in my domain, and it will have all the documentation for the project, everything, 3D models, footprints, symbols, data sheets, everything. And so all you have to do is go there and look, and you can get it from there. So I guess next thing, everybody should have downloaded Fusion 360 and signed up for an account by now. So if you haven't done that, go back to the previous video, number 4, I believe, and then it just shows you. It's easy. Just go to Autodesk, and it's the Fusion 360 Personal Edition, and download it for free. And so now we have an account and Fusion 360 on our computer, and so now we're going to go load it up, and we're going to start building a project and a schematic and all that stuff. Okay, so we come over here to Fusion 360, double click, and it'll start loading up. Has to log you into the cloud and all that stuff. Initialize everything. Establish a connection. Alright, and you should see something like this. You won't see these because these are the main brain, my main brain stuff. And so you need to first you need to create a new project, and that's just creates a folder to keep your stuff in. So I'm going to call that IO board, and you can rename it later too. It's no big deal. It gives you a place to put your files. So then the first thing you want to do is create a new electronics design, because you can do mechanical design too. So we're going to do electronics design, and then you're going to want to create a new schematic. Okay. All right. So then you got your blank schematic, so then you might as well save it right now. And you can call it what you want, but schematic is good for me. And then you need to tell it where you want it. So we want to put it in our new project that we created, and then you just hit save. And so then that puts it in here. And so then you got your schematic, and then you probably, let's see, we need to go to the IO so that we can go to the electronics design here. And that'll take us back so that we can create a new PCB. And it should automatically link it to your schematic. So it says up here you want to save it, so we should save it right now. So we call it the PCB, and that's good. It automatically selected where we saved the schematic, and then we just hit save. And so now you have your PCB and you have your schematic. And all right, now before we get started, we got to create one more thing. So we got to go back. I don't think we have to actually go back to this electronics design, but it doesn't matter. And then we want to create a new electronics library. Okay. And then we have our library here. So then you're going to want to save that too. And so the library, you probably should name it which library it is, because just having library as a name will get confusing later. So I'm going to call it IO board library. Okay. And then the location we're going to save it at is in IO board for me. For you, whatever you named your project, and then we'll save it. And so now you got the three basic things that you need. Okay, so the first thing you're going to want to do is probably come over here to the PCB, double click, and pop that up. Okay. So that's your board. So since we're doing something specific, like we're building an IO card to mount underneath main brain and interface with it like it was intended, we have to make the PCB shape and put the 4 holes in for a main brain to mount to. Okay, so the one thing that we need to do first is come up here to the view right here, and then we want to do the grid settings. So we want to change the grid settings to millimeters, because I don't know about you, but mils just doesn't fit with me too well. But I mean, if you want to do mils, that's fine, but I'm going to be doing millimeters pretty much all the time. So okay, so then that puts your dimensions in the millimeters. So over here, this is your layers. There's all kinds of layers for your PCB, and the top and the bottom is going to be the main traces and stuff, and then you got different things like the silk screen and different layers that you can have documentation. And then one of the files required to make your PCB in the factory is a drill file, which is made automatically. You don't have to worry about that. But for right now, we need to size our board. So we come over here and click on this line. This is your origin here. This is 0.00, so everything comes off of this this origin here. So right here you want to click on the line, and then you can make the length, because it goes from 0 to 80 millimeters. So main brain is 63.5 millimeters there, and just hit enter. And then we want to come over here and do the same thing here. And 63.5. And then we got to do the length, so you click up here, and from 0 to here, and then you got the bottom one here, and from 100 to 0, and it actually should be like 0 to 100, but anyway, so you click here, and so it's 63.5, and we want it to be 96.5 long. Hit enter. And then we want to come down here like that and change that 100 to 96.5. Hit enter. And there's our board. There's the size, the main brain right there. So the only other thing to do is to put 4 holes in it with a 4 millimeter diameter. So you go up here to the place right here, and it's going to be a plated through hole right here, or actually it's non-plated through hole. And we're just going to change the drill size, because you have a drop down for most sizes, but it doesn't go all the way to 4 millimeters, so you just override it by putting 4 in there, hitting enter. So there's your hole. So you just put it here, let it snap into place about right there, and click, and let it snap into place there, click, and snap into place, click, and snap into place, click. And then you just hit escape to get out of there. And so that's the basic thing right there. So you just have to make sure the holes are centered right. So we'll come up here. We have to do document, and then we have to do dimension. And so dimension's a little bit tricky. You click on the hole and it goes from the center, but it does the diameter by default. So you just right click, and then that puts it into the regular mode, and you click, and then you move up like that, and then you got your dimension. So it's 88.9, and that's exactly what we want. And so then you do it again here, click your dimension, and go here, right click, brings it down here, and we can see that it's 55.88, and that's 55.9 by any standard. So that's good. So I'm just going to hit escape because I don't really want that. So then to go back to design, and to delete something, you click on this big red X, and then you select what you want to delete, and it deletes it. And so that's our board right there. That's the minimum requirement for main brain. And so then we want to save it. So you come up here and save it. And you can name each time you save it, like, because it keeps track. So you can revert back, but it doesn't matter in this case. We just save it. So now, the only other thing we need to do first, before we start drawing a schematic, we have to go import parts into our library. So let's double click on the library, and so now is what we need to do. We need to have parts to put in the library. So the very first thing we have to put on main brain is the I/O connector. And then from then on, it's anything goes, whatever you want to do. But the minimum requirement is the form factor of main brain, and to get that I/O connector on there in the right spot. And then after that, we can start drawing a schematic. Okay, so we got our basic thing going on for fusion, and so the very first thing is we got to put parts in our schematic. So since we have to get the first thing is to get that connector on there. So let's find the 3D model for that, and the footprint and the symbol, and we'll put it in our library, and then we'll place it on our schematic, and we'll see how it propagates over to the PCB, and we can move it into place of the PCB, and then we'll see how it looks on the 3D model. So the first thing, you got to find the part. So I have the bill of materials on the public folder of my website. So you can get it there. That's the first thing. So that'll give us the part number. So let's do that. Okay, so we're going to open up our browser. And first, we're going to go to the my public directory. So we'll go antimatter.me/public with a capital P / and that will give you a directory listing of what's in there. And so right now, I have your models for the connector, and I have the bill of materials for main brain, and then I have a data sheet for the connector. So right now we're going to do it the long way, how you would do it when you want to look up your own parts and stuff and get your own libraries. So we're going to open up main brain ODS, which is a spreadsheet, and I use openoffice.org. Well, OpenOffice, and you can get OpenOffice for free at openoffice.org. It's like Microsoft Office, but free, and it's under the GNU license structure. And so we're gonna open up this here ODS file, and it gives you all the parts in main brain. So this is how much it costs actually for me to build one main brain. Anyway, so we want to look for the connector, and it is right here. It's the 68 position surface mount J4, and this is the part number here. We're going to copy that. We don't need that anymore. And let's open up another tab, and we'll go to digikey.com. And DigiKey, I get all my parts from DigiKey. Well, as many as I can. I can't get every single part from there, but I get like 90%. And the other parts, I look around and I try to get parts on eBay, because you can get some pretty good deals on eBay for parts too. Buy more than one, you can buy 10 or 100 or whatever. And it saves you money. Yeah, okay, so now I would recommend signing up for a free account with DigiKey. There's a lot of added features, like it keeps track of the parts that you order, and you can go back and look at them, and you can reorder them, and you can build a bill of materials to keep on their cloud. Yeah, they got some pretty good services, and I've been ordering from DigiKey since I was a teenager. And that was a long time ago. So, all right, let's paste our part in here, part number, and hit search. And so that's our part. And so the data sheet, DigiKey almost always has a data sheet available. And so I would recommend getting this data sheet and saving it. I have it posted in the public folder, and get familiar with it. And you can figure out other options too. If you want to build a project and use this connector or a different connector, you need different amount of pins or a different size or whatever, you got to start at the data sheet. All right, so I have that already. I don't need it. But then we have our models here. So if you click on here, DigiKey shows you 2 places you can get the parts. SnapMagic, I would recommend signing up at SnapMagic for a free account, and also Trace Parts for a free account. I don't think Trace Parts will allow you to download without a free account, or an account. So it's showing a 3D model here for SnapMagic. Let's try it and see. So the step is your 3D model. So let's just download that and see if we get one. Because before they didn't have it. So looks like they have it. So let's save it and open it and see what they got. So let's go over here, File Manager, and go to our downloads here, and let's open up that zip file. Yep, and it does. Okay, so yeah, I requested it earlier, and they did it pretty fast. I'm surprised. So we can use SnapMagic then, I guess. So let's select download format. So we want to get the symbol and the footprint. So we got our step. So then we want to come down here, and it looks like Autodesk Fusion. Sometimes it'll just be Fusion 360, but here it's Autodesk Fusion. And also, if you can't find Fusion, I guess Autodesk has Eagle, and you can use that, and it'll work in Fusion too. So then we'll download that. And so we got a zip file again. Alright, so we download that. Let's see what we got in there. So this is the first one we got with our step, and this is the second one we got. So they just gave our library. So usually when you download, SnapMagic just gives you the symbol and the footprint, and then you have to do the 3D model separate. So we got both of them now. So it's what you want to do while you're here. Let's extract this, and I just put extract all, and then just extract it right there. My downloads directory has just a big pile of stuff that I download, and it's just not organized in any way other than sorted by date. So then we want to do this one too, extract all. Okay, so I created 2 folders here. One is your library folder, and that contains the symbol and the footprint. All right. And so then the other one, that contains your step file, and that's your 3D model. So we got all 3 things that we need for Fusion. Okay. And so, like I said, over here, they're in here already. So I just wanted to show you the long way so that you knew how to do it and the process how to do it. So let's close this up and let's go back to Fusion. Okay, so here we are back in Fusion, and we're in our IO board library. So we want to create a new component, and we want to import it from a library, but our library is on our local disk, so we need to import it into Fusion. So we open the library manager, we come over here, and I already have this in there, but you'll want to hit this import libraries, and then you want to import it from the local disk and go to where you downloaded the file and extracted it from the zip file, and double click on that, and that brings it in. So you have that in there right now, and so you can close the library manager, and so now you can pick it from the part here, so from the list. And so there's our part number, and underneath there then you see the footprint here and the symbol here. Alright, so then hit OK. Alright, and so this is your footprint, and you can edit it and change it the way you want, because I like to change the pin numbers and the name and stuff, and sometimes I don't want to have the value displayed, and It's just whatever you want. And you have to, when you can also create new footprints and new components if you can't find one. That takes a little time, and that's another subject for later. So we want to go to our schematic, double click on that. All right. So now we want to place our part. So we got our layers list here. So if we double click on the display layers, then that takes that out. We can go to place components. So that's kind of what we want to do. Let's get this out of here, Divine Manager. All right, and that gives us a longer list. If you just want to expand and contract these things, you just double click on them right here. And so we come down and we must find our part number in the libraries. Well, we got to select our library first, because that's all libraries. So you just need your library. So that is I/O board library. Okay. And it didn't put it in there. So let's hit edit library. All right. And so that's in there. And what are we supposed to do now? I guess we save it. Yeah, that's what I forgot to do. We got to save it when we're here. All right, so now that we saved it, it's in our library. We can go back over here to our schematic. All right, and then we have our library in here now. And so we don't want that exactly. So what we want to do is double click on this, and it'll put it into our schematic, and then we move it wherever, and we'll put it right here for now. And then it'll want, you can make multiple copies. So once you get it one place, you just hit escape. And so now we got your connector in here. So let's go to our PCB and look and see what happened over here. All right, so now, and you can use, I don't know if your mouse has a thumb wheel, use it to like zoom in and out. And so here's our connector, and we need to put it on our board. So you go up here to the move, and you select your part, and then it moves. Now if you want to rotate it, you just right click. And see, that's 180 degrees from what we want. So we click it again, and one more time. And oops, like that. And then we want to put our part over here. No, that's actually backwards. It's actually supposed to be like that. So we want our part to hang off a little bit. That's up to you. I kind of put mine just barely on there. And you have to make sure it's centered good between there. It's important that it's centered to match up with the other boards. So just click to place it, and there. And it's right in there. That's your part on your board. Okay? So then if you go back over to your schematic, then you can place other parts from your library or other libraries. So you can select other libraries in here. Say if you want a capacitor. So there's different things, and you just have to figure them out. That's why I like to create my own, because I can name it the way I like it and stuff. But anyway, there's a cap. It's a chip cap. So if you just double click on that, and you bring it over here like that, and you can place two caps like I was talking before. And then when you're done placing, hit escape. And so now you got two more components on here. And let's say, just for practice, we're going to connect a trace on here. So you come up here to connect, and you click on the net. And so like maybe from B1, you want to connect it here, and from here to here. All right. So then let's go look what it did at the PCB. So it places your components and they're connected by that trace. So you want to hit the move and you click your part and you want to come up, and if you want to rotate it, you right click. So I want this one like this. And then if it doesn't like a line 90 degrees straight like you want it, hold down the alternate button, the ALT button, and you can do a more finer movement. All right, place that there and come down here, select that one, put this one up here like that, and then if you want it to align in a more fine position, hold down the Alt key, click, and that places it. So now you have, this is your trace from your schematic over here. That's this right here, represented over here in your schematic, or I mean in your PCB. So this lets you know, and it won't let you place a trace in the wrong, on the wrong side. So then you want to come up here and you want to do a manual route, and you click your pad and come over here, and it won't let you go down here. You can't accidentally or even intentionally place it here, because on the schematic it says it has to go to this net right here. And so over here you can select if you want right angles, if you want curved. You can do a lot of different things, partially curved, and you can put it right on there, just like that. And then if you want to move your trace and straighten it out, then you go back to the move, and you can either move the component to straighten it up. Are we on move? Yeah. And there's something it doesn't like. All right. Yeah. There we go. All right. And you can change the grid too. You can hold down the alternate so that it's a finer movement, finer alignment. But you can also come up here, and where we went to grid settings before, and we're back to mills because this is the PCB, I guess. I don't know why it changed. Maybe I closed it earlier when I was messing around. But anyway, millimeters. And then you can put finest. You can tell it how fine of a pitch you want on your grid to snap to. Finer pitch parts like we're using, we probably want to go maybe 0.127 for our regular, and then 0.127 for our fine. It's up to you, whatever you like. This is where it becomes your project. So we click on that. Oh, we got to come up here to move. We click on that, and then we can move it however or wherever we want it. And if you don't like the way it is, then you just come over here to the X and click it, and it's gone. And you never lose your connection to your schematic unless you delete it on the schematic. But the PCB always follows the schematic. All right. So now, I don't know what just happened there. Cancel. Something really weird just happened here. Okay. All right, so now we got this. We probably better save it. And now we need to, well, we don't have to, but the next step is for your 3D So you want to come up here to switch, and you want to push to the 3D PCB, okay? So then it's going to come over here, and then you have a button. Sometimes it shows up down here. It depends on how you set it up. But you want to push it, and now it'll start creating your 3D PCB. So there wasn't many parts, so it went pretty fast. And so here you have your part, and you can look at it. That's your home view right here. And you just click on the front or whatever, and you can click the box and drag it and however you want. And if you want just a flat front, click on it. So here's our thing, our board. And we just have like the basic stuff. We don't have a really good representation of this. So we got to get our 3D model in there. So we come back to the PCB and you select, you got the arrow for select, and so you click on it. Now if you right click, it will say add custom 3D model. So when you do that, you click OK, and then you can name it. That's what it's called. That's okay. Maybe I want to call it J4, whatever. Save it. And then you got to find it in here. And you'll have to upload it. So you click upload. And that's in your I/O board folder. And you want to select the file. And then you want to go to your step file that we downloaded and extracted from the zip file. And double click on that and upload. Okay? So that's going to upload it into your folder here in your I/O board. And it takes it a minute sometimes. Sometimes it'll hang up and you have to do it again. It's the connection between your computer and Autodesk Cloud. All right, so here we are here. And this is our step model that we just uploaded. So you want to right click on that and you want to insert it into the current design. And if you're lucky, it will do this and go right in on the footprint. And you have to double check, click on the right and make sure that it's on there on the lines lined up properly. Because sometimes it won't. Sometimes you'll have to manually align it yourself. But that's on the pad, so that's the way it would be on the board. And so you go up here to finish and you just click finish and you want to save it. And okay. Okay? So now it tells you that the 2D image of your PCB doesn't jive with what's in the 3D file. So you want to come back up here and push to the PCB, 3D PCB, and then see it comes down here with your push, and you hit the push button, and now it should load your 3D part onto your 3D PCB, just like that. And you can edit this too, right here, with all this stuff, and that's for a later time. So there you go. I think that's all we're going to do for today. And that'll give you time to play around with your schematic and stuff, and then the next video we'll design our board. All right, so there you go. That's the basics. We got our schematic software all set up. We can do a schematic, we can make a PCB, we can do a 3D rendering of our design. We can import footprints and images into our library, and we can get our library into our project, and so we're ready to go. So it just takes a little practice, and once you get moving schematic parts around and connecting them and this and that and everything, it gets kind of easy. And there's always something to learn. I've been doing it for a year now, and there's still, I had to go do this video and a few edits, let me tell you. The next thing is we have to fully define our board now. It's not, I mean, at least the first revision. So we're going to have to start picking components that we're going to put on in our board and do the schematic for it. So we got our connector, and so I'm in the process of finalizing the design for the interface to the board. So on the next video, we'll probably get the interface chips between the I/O connector and the rest of the logic on our board. And then we'll have to pick a microcontroller, and so we'll go through that, how we pick it, and then we'll decide which modules we want on our board, you know, like the digital and the analog and stuff. And then we'll pick the components for that, and we'll get our schematic lined out, at least for a first revision, and get the parts arranged on our PCB, and then we'll go from there. So I'll see you in the next video.